Good afternoon, all. Hi, Robert Putter here, Director at Cresco. I think some of you have heard me speak before on these various webinars. Apologies for the Cresco marketing placeholder while we allow everyone to join the call. And thank you for joining us on our, monthly webinar, although July was a bit busy with holidays and running around. Today's focus is really optimizing resilience of supply, both grid-tied and off-grid sort of approaches. And it's myself speaking, Nicola from Juby, Kobus bringing the mining angle, and Jevon bringing, both the previously in mining angle as well as the wheeling trader angle to the discussion. So I hope you look forward to the 1 hour presentation. Standard rules apply. You don't have to take screenshots. You will receive the presentation afterwards as well as the recording. Please post your questions in the chat and I will endeavor to answer as many questions as can be in the timelines, and then any questions of reasonable length that aren't answered, we will try and do in the follow-up presentation. I hope you will join us in September, where we're looking to do a hydrogen webinar, and then in October, where we're looking to do one on transmission, specifically in the SAP region, but also then talking about the ITP program that was launched earlier this week. So these were the bullet points that were in the invite. I think, as always, when you get closer to the presentation, these things change. But I think from a broadly perspective, most of the key points will still come out. Next slide, please, for me. So really, from a Cresco point of view, we're seeing significant market liberalization coming. And I know we could spend an hour talking about the Eskom court case. For us, it's maybe just a bit of a blip, or a bit of a major blip in the road. But that's what's there. And I think we're seeing the market move very much from a bilateral market down to the aggregator market. And if the stars do align a bit, eventually, hopefully next year or shortly after April next year, we might have a bilateral or open market, albeit Eskom only. And then eventually in 2029, we really see a multi-market with private sector fully engaged and also selling ancillary services in that. But I think the value of BESS, which is our focus today, is really around how can BESS assist clients in this focus. So generators above 10 megawatts will be exposed to imbalances, and we're doing a lot of the work at the moment around looking at how BESS can provide support, either guaranteeing generation in certain periods or at least assisting in sort of negating the financial impact of those imbalances. We could have a whole separate discussion around balancing and timing and things like that, and please reach out to us. Happy to talk about that. And then we're also seeing a change in the way PPAs are done in terms of capacity payments for BESS, or if it's a wheeling project, sort of part of the generation profile. And we do also see a changing approach for BESS. Perhaps that now you might over time move into capacity market. So a bit more of a merchant type approach to BESS as opposed to being part of the project financing. We also see variable single energy tariffs replaced by time of generation tariffs. And as Cresco and an advisor to many off-takers, we think that's much better because that allows you to compare a Eskom time of use tariff with a renewable time of use tariff. And we also see that BESS is definitely playing a role in that to give comfort to the off-takers that the generators can achieve that. And then I think we've all confirmed that the value of BESS, specifically for on-site, is definitely validated. For off-site, for peak shaving, we believe there is something there. And then a number of questions are now being asked around standalone BESS, not necessarily in the government program, but in terms of how does that fit in the mix. And so I think most of our clients have some BESS strategy of some sort going forward. Next slide, please. Just click through to the end, please, Amelia. Yeah, so as you're aware, Cresco has done forecasting. We got load shedding right on the 1st of February, but we didn't pick it on the 1st of April earlier this year. So you have some good and bad. But we had a view in September. We have an updated view in June based on the rollout. And I think our view is largely the same as the one that we presented in February, both unfortunately and correctly so. So I think we still see continued coal decommissioning. EAFs are slightly up, but perhaps not consistently up on last year. We are still very concerned around large-scale gas only coming in from 2030. I think the government, this briefing note on the gas procurement is a serious concern. And I know the terminals are also quite far away from actually achieving some of the timelines that are there. We're all aware of the delayed renewable rollout, both government and private sector, because of the grid issues. But what we have seen outside of residential BESS, because I know there's been a number of high-profile failures of small residential BESS provided, is a large increase in BESS installations of scale. And we had the successful MTN project, and we've got a number of other mining projects now. But most of these BESS installations at the moment are actually behind the meter, so on-site BESS between 2 and 4 hours. And we continue to see that increase over time with both wheeling BESS coming into the system. So one of the things we have revised is we've increased the amount of BESS coming into the system, and we're quite excited about that. At the moment, it's primarily lithium ion, unfortunately. We are seeing some other technologies raise its head, but at the moment, if you speak to an EPC contractor, that's the technology that they're willing to put their balance sheet behind. The other stuff is a bit of a marketing tool, but maybe Nicola, you could touch on that in your next slide. Next slide, please, Amelia. So I think what's quite interesting is that we need to consider how BESS plays within the seasonality of the market. So as you know, we've done projections on an hourly basis, both in January and June. So using a summer month and a winter month, both in terms of generation profiles as well as load. And you can see this is outside of the coal, but you can see we have a winter heavy generation profile. We have the solar being significantly reduced because of the shorter daylight hours. We have imports being quite seasonal. And then we see significant BESS sort of coming into the system there in 2025. Well, not smaller BESS coming in to help the grid. And then in January 2030 and June 2030, you can see significantly more BESS projected into the system, both to help peak demand, which has always been a problem based on our curve, but also slowly, I think, in the early mornings, because we are seeing that the grid is going to be constrained in the early mornings, and we need sort of the BESS there to support the grid over the time, because unfortunately by 2030 we won't have the gas, and we believe there isn't a huge opportunity in that situation. Next slide, please. So just using BESS as a scenario. So as I said, we're doing a fair bit of analysis. This is just an extract. I'm not going to go through all the numbers, but at the moment we know PV only is a no-brainer, although PV only is going to become a concern over time when we might have excess energy in the middle of the day. Plus Cresco's view is that we'll have off-peak in the middle of the day, so that will reduce the value from BESS. And then larger scale BESS, we can see that actually the savings are still quite robust under the scenarios we have, specifically in terms of taking energy or PV in the middle of the day that perhaps is becoming less valuable, and injecting it and charging the BESS coming out. So, you know, we're quite excited about the BESS, albeit at sort of 2 to 4 hours at this stage. Next slide, please. And then the next one is around large scale BESS. And here we do see the requirement to really dispatch the BESS as much as possible. It's your most expensive asset. Let's utilize it. So we are seeing that charging the BESS during the day to dispatch in the early evenings, and then once again charging the BESS in the early mornings with the cheaper off-peak. So one value of the Eskom retail tariff plan is that off-peak has become cheaper, although the fixed charges are there, and then benefit from the early morning peaks. And one of the Cresco views is that we will get another early morning peak. So we'll have 6 peak hours in the day eventually. Eskom does use peak as a way of driving demand, and we think BESS is there to supplement, as well as there will be a reduction in demand. So happy to have further discussions, but from our point of view, at least on-site BESS, even of scale, makes real sense, and it's all about BESS utilization to get the best out of your most expensive toy over time. Thank you very much. I don't believe there are any questions for me from what I've seen, so I'm going to move on to Nicola.
Thanks, Rob. Right. Thanks very much, everybody. Good afternoon. I'm Nicola Cincilli from UV Renewable Energies, and today we are diving into how we can, or how we have been building grid resilience for large power users. Kind of focus this presentation mostly on some of the mines that, and we would like to present case studies of real world projects that we've worked, but of course this does extend to all large power users. Next slide, please. Thank you. So this is just a brief introduction. At UE, we've been powering the mining industry since 2014. These are some of the clients we've worked with. We do provide a large suite of services, well, project development. We do EPC and we do EPCM. In fact, so EPCM is interesting because it has emerged as like a prominent service in the market, in the local market. And we're finding that it's a particular preference for large power users who want to have greater control over their power generation. Thanks. Next slide, please. Right, let's talk about some of the challenges of building solar PV on mining land. So we do face some tough conditions, climatic conditions, rainfall, etc., that need to be measured and evaluated. It's not quite as easy as just installing PV panels in the ground. We've got some tricky ground conditions on mining land, which is very different to a greenfield kind of site. We do need to manage quite carefully with with community relations, although I must say, when working with our mining clients, they really give us a great avenue to work with the local community because they've done so much work there already. Subcontractors is, well, I mean, some of the subcontractors that we deal with, they're fairly happy to bury their mistakes below ground. So that's a challenge. You need to do quite a bit of quality supervision, and some of these sites are quite remote. So you're constrained by who you can use. Grid code compliance is something that I'll speak to shortly in the next slide, because that's quite a big piece of the puzzle. And health and safety requirements on mine sites can be very strict. So the new challenge that we're finding for our clients, for large power users, is that it's strategic. You want to increase renewable energy penetration, but you also want to build grid resilience. Next slide, please. So renewable energy grid code compliance. So this is one of the biggest hurdles that we do have to comply with. For example, the Elikulu PV plant, which Kobus might speak to, that's what we built with Pan-African Resources. That was the first behind-the-meter project in South Africa which could achieve grid code compliance. We did need to do quite a bit of changes to the grid code there, well, or looking for exceptions. Effectively, the reason why it was so tough is because the grid code doesn't quite apply to behind-the-meter generators, and especially not in this case, it was a zero export generator. So remember that the renewable energy grid code, it has requirements which are quite a lot stricter than you yourselves require for just a pure load. So it's not cognizant of the fact that when you're doing your quality of supply test, you actually have a large fluctuating load with a very poor power factor sitting there. It absorbs a lot of the reactive power, and the PV plant really needs to beef up to be able to meet grid code compliance. It's quite tough, but we managed through extensive engagement with Eskom, and you'll see there are many more behind the meter projects which are happily grid code compliant, except for a few exceptions. I did want to make a note, though, that this is changing, and what we see is that with the inclusion of BESS, or battery energy storage systems, they can provide a lot of the reactive power compensation that you need, or as a fast response. So we're finding that it's much easier to smooth grid disturbances for the load, and it's much easier to obtain grid code compliance when we have a co-located BESS system. Thank you. You can do the next slide. Okay, case study. This is the Sukari gold mine. Let's take a look at a real world example. This is a gold mine in Egypt. Thank you. Yeah, it's completely off grid. They were burning diesel 24/7. So they had a huge power bill. And they were also, I mean, they could not experience any energy failures. Even a short power disruption was a huge issue for them. So solar PV plus BESS was the best fit. lots of sun, plenty of open land, and we were able to move quickly to the market and provide the best system as well, which was for energy security. Please, will you pass to the next slide? Yeah. Okay, so we did experience some significant hurdles. It's a 36 megawatt peak PV system with just 7.5 megawatt hours of BESS. There were health and safety challenges. I mean, we had some contractors who, I mean, there were sort of some there were some injuries, like the, you know, a hammer on the thumb or something like that. Minor injuries, which invariably we had our site shut down for a month. So we had to rectify very quickly to be exceptionally careful, even with minor injuries. And then there was the debacle at customs, which was quite an experience. There seems to be a very strict requirement in Egypt for communication equipment. Our comms equipment got held at the border for like 6 months. So we effectively had to commission the plant and run the plant 3 months using off-the-shelf switches, comms switches, which we could get locally. And fortunately, we were able to adapt there, but that was probably the biggest challenge at Sukari. And of course, we faced harsh soil conditions. The desert is not exactly the most. It's certainly a trial to install tracker posts in desert sand. Yeah, thanks. Next slide. Well, the payback was pretty good for Sukari and for us. We delivered a solar PV and BESS solution in about 18 months for them, and we cut diesel use by 70,000 litres per day. 57,000 tons of CO2 emissions were avoided, and I mean, I think what Centamin and now Anglo Gold Ashanti were exceptionally happy about, was about the $20 million annual savings due to fuel avoidance. So this, so Sukari with the BESS and the control unit and off-grid system, it's a great example of how renewables can deliver both economic wins and energy security for the mining sector. Thanks. Yeah, that's it for me. Thank you.
Cool. Thanks, Nicola. So before Cobus goes on to sort of bring the other side of the story, find out if he blamed you for not getting through customs or not. Two questions for me. One was, so we obviously model in Excel and these fancy softwares, the grid charging and all these other bits and pieces.
Yeah.
But what have you seen as actual real technical constraints in the BESS? So one of the things that I know the grid operator in the UK, for example, is they won't allow BESS to dispatch as an ancillary service, I believe, for more than 15 minutes, because they just don't trust it at the moment. Is there any specific technical issues that you've seen from operating that people need to think about that don't come out in the software analysis or the real life examples, right?
Yeah, I mean, obviously, so BESS is punted as being able to do, arbitrage and to be able to reduce the variability of power output from your PV plant. But I think some aspects of it which are missing, which you really need to ensure you design into the system, is what kind of inverters are you using to move from the DC to AC, and how are you infiltrating that or putting that back onto the grid or onto the loads distribution sector. So if the inverters that you select, they're going to have to be grid forming at some in some instances to be able to provide the services needed. Those are expensive, and I'd say that we've seen some intermittency in how well the technology works. So really, I mean, we play it safe, and sometimes the response time of the BESS plus inverter system that you get, we can't always meet the response times that one would hope for, or that the grid load requires.
So does that mean you're sort of running spinning reserve in the background, or does this project, is it completely renewable when it's fully going in terms of at that time of the day? I know it's not completely renewable off grid, but are you still running some spinning reserve even when the battery is dispatching or not?
Yeah, I mean, well, so for Sukari, they do have the diesel generators as well. But no, I mean, we are able to feed with BESS. Essentially what we're talking about here is fault ride through. any disturbances on the grid. So it's sporadic. You might actually have a situation where you do need to if you don't have PV at that point in time, you can't only rely on the BESS system to be able to provide stability in the grid. You do need additional backup to be able to meet grid disturbance requirements.
Yeah. And just touch on the technology, lithium ion or derivative, or did you get
Yes,
anything
we
else in
do.
there? And how much is Juvi willing to back a new technology with its EPC guarantees at the moment, or is it still early days?
Yeah, I mean, look, we are conservative. We like to use a technology that is already well known and deployed at a large scale, and that is the lithium-ion batteries. I mean, cost-wise, I think that's probably the preference why we are going for lithium-ion batteries. But in terms of like response time and also in terms of power density, like flow batteries are. I mean, I think we're going to see a change because, I mean, I don't understand the technology fantastically, but I think they do have like a longer lifetime in terms of the number of cycles they can provide. They have a larger footprint and they're more expensive to install up front. So yeah, I mean, if our client is willing to foot the bill, we'd be more than happy to do a flow battery, and probably be better for the lifetime of the plant.
Okay. Then last question is around bidirectional meters, right? Because we have, I think at the moment, 60% of Cresco's work in the development phase assistance is helping with on-site projects, and only 40 sort of wheeling type things outside of strategy. And in that scenario, we do see that you might need a bidirectional meter, because if the mine has a unplanned maintenance event, you want to put it into the grid, or in many cases, you might even have export capacity available, or if the life of mine runs out, you obviously want to sell it. Any comments around bidirectional meters and maybe even grid compliance asides? We'll leave out Eskom's willingness to take the grid, because take the energy, because that's a separate discussion.
Yeah, I mean, because we're exposed to the execution side, I mean, it's a challenge because you're sort of subject to the same grid queuing rules as straight embedded generators that are not as normal generators. So it's a challenge to get onto the grid. But I mean, I think like to engineer and design and install bidirectional meters and allow for that in your control system, it's not an issue. I think it's just getting past Eskom and then being fitted with the bill of having to pay for upstream costs. Yeah, so that's I mean, but that's kind of what we're seeing from clients is a sort of a form of frustration that they are, even though you've got a PV plant, BESS plant that is helping to reduce your load because it's behind the meter, they're not actually able to consider export because the way that Eskom sees it, there isn't a capacity on the grid at that point, as if you had your PV plant as well as the load running at the same time. So yeah, it's a challenge to get past Eskom.
Okay, cool.
And get the design.
And then last question, because I don't see any in the chat, and I think I'm finding this interesting as an accountant speaking to an engineer. Engineers are always cleverer than accountants. Is to throw you under the bus a little bit. So in the SAWEM market going forward, we have this requirement for balancing, right? So 10 o'clock in the morning, anyone above a 10 megawatt generator needs to predict for a 24-hour basis on an hourly basis your generation. Now, the project you're talking about here, I know is not in South Africa and is not good, but assuming you had this sort of project size, because it's got a fairly significant base, would you be able to give with quite a bit of confidence that forecast because of the size of the base, as opposed to obviously a PV only? And therefore, how much do you think that base requirement might influence the balancing going forward? Because I do see it in my slides earlier. I don't know if you could talk to that, or is that too detailed?
No, I mean, we're used to forecasting. I mean, because of the operations and maintenance that we do on our existing PV plants. I mean, and since the beginning, Eskom's had, well, I mean, the REAP PPAs, the extent of forecasting wasn't as severe as it is as what we're seeing now. So forecasting, we just with the straight PV plant, I think we're able to get it into the right range. It is great to use BESS to be able to supplement. But we would only use that if the penalties are higher than releasing power from the BESS during during peak times. And actually, generally the penalties are not as severe. So I think what we would recommend to clients is, you could take a hit on the forecasting, and getting the forecasting wrong, because you'll only be off by 2%, maybe 2.5%. We're very good at estimating what tomorrow's power is going to be like in half-hour increments. Rather take a hit on the penalty on the forecasting and reserve your BESS for peak if you are going to feed into the grid.
Cool. Thank you very much. Thank you for taking my questions. Kobus, do you want to give us your side of the story? Thank you very much.
Oh, thanks very much, Rob. Next slide, please.
Do you mind just popping on your camera?
Good afternoon, everyone.
Sorry, Kobus, do you mind popping on your camera?
Sure.
Thank you.
I was invited by Juby to co-present under this section, and excuse me, I have a bit of flu still lingering around. So a great pleasure to be here. Basically, I've been working with a really great gold company called Pan African Resources that are London and JSE listed company, really progressive and very successful, in particular now with the commodity prices where they are. And a really great company in terms of de-risking their mining operations, moving over to surface tailings treatment material versus the classical underground mining. So I'll speak more about the relationship, the triangle relationship between myself, UV, and Pan African a bit later. So about 6 years ago, Pan African asked me to start getting involved with the renewable energy ambitions, and we immediately planned the first project, which was the Ilukulu, or the Evander solar plant. That was built at Evander Mines. That's a just under 10 megawatt, 9.975 megawatt AC facility. And then subsequently, the Barberton facility was built. The reason why Pan African wanted to move into the renewable energy space was, first of all, for energy security reasons. But we soon found out that in the early days, that if you run a PV plant and there's no grid, that also doesn't work. So without a decent base coverage, you're dead in the water. But the main reason for them having decided to follow this avenue was the economics of it. With the superinflationary Eskom increases, it made complete sense to buy the only better, to build and develop the only better generation plants. So over and above these two plants, they are also still developing two further plants, approximately 25 to 27 megawatt peak each. The one will be located again at Evander, but at a different shaft, 8 shaft, whereas the first plant was built at 7 shaft. And then they recently acquired the minerals tailings processing, Mohale tailings processing facility in Krugersdorp. And again, that will be a 25 to 27 megawatt peak plant that they'll build. Obviously, the economics of behind the meter plants are phenomenal. You don't share with an IPP in terms of an inflation increase model and the power purchase agreement. All of the benefits are your own, and even your commissioning power starts being for your benefit on day one. Then Richard and Nicola and myself thought it might be interesting to just, on the last slide, speak a little bit about how the miners' perspectives have changed regarding in particular solar, and then also what the latest thinking on the senior debt level is, and the lenders' perspectives. Next slide, please, Rob. Thanks. So really, this is a continuation of the fact that Nicola has also highlighted the risks here. In particular in mining, there's, mining is very different, the land there, in terms of there being all sorts of things underground, legacy material, steel, and so on. So it's not as simple as buying a piece of farmland and doing your geotech there. So there's a lot of things happening underground. And then building on unstable ground also increases the risk of structural change or damage through solar analysis. Now, what happened was at the Evander plant that was built first, and sorry, I forgot to mention, the reason why it was called the Ilukulu plant initially is because we thought as a first plant, we should be connecting it to a load that's even and doesn't have a lot of ups and downs and massive loads coming through suddenly, as you would have with the shaft and so on. So the Ilukulu tailings plant was absolutely perfect for that, and it was built with that level, sort of almost low profile in mind. This project was built on a legacy foundation that was broken down. It was a hostel, a huge mining hostel, and it was demolished, and all of the remaining rubble actually stayed on the site. UV then took a view and said, we'll tackle this, and they actually made a success of it, despite the difficult ground conditions. And so there we are. That is just an example of how things can be done. But there was a lot of design work and thinking in terms of civils in particular to make sure that it's stable. Then the second risk under here is in terms of geotech is soil contamination. So as you know, with mining, you often have legacy tailings and things that you don't know about that was dumped, specifically in gold, dumped somewhere and forgotten about. So, with the fact that the contaminated soil requires remedial efforts and so on, you don't want to mess with the groundwater and so on. So that's what actually happened at the Barberton plant, the Fairview plant. We did a proper geotech as we always do, but you will not believe this. It was 100-meter hole spacing, and between 4 of those points, there was a whole lot of legacy ground material, old tailings resident there with completely different geophysical and geotechnical characteristics. So it was a big shock for the whole project, but when we started thinking and putting our thinking caps on, we analyzed the gold content of that material. It was sent through to the mill, and the additional gold they more than paid for, compensated for the cost of the additional material that had to be brought in and compacted. So a good story again there as to how you can turn a problem into a solution. Next slide, please. Then groundwater issues, always an issue. Mine sites are not perfect. There's a lot happening. And, mining activities can affect groundwater levels and flow patterns. So flooding and drainage problems always appear. You need to make very sure that your stormwater management systems are properly designed and built to be able to prevent water from building up and standing and ponding. In particular, where you have an angled site or an angled site with a larger angle and more challenging topography. So this was the case again at the Barberton plant, where it was quite a steep site and not flat at all. And there's now still some work continuing on the sort of refurbishment and correcting of the groundwater system, which after it was built, we found some issues with it when the rain started. So not easy, not straightforward. Thanks. Next slide. Then site conditions. Specifically, when you're dealing with open cast operations, and tailings recycling operations, there's a lot of dust that is generated. Soiling can really hurt your yield and your generation production. When you start looking at 1 or 2% production loss, you are worried but not concerned. But once it gets to 4%, that becomes really material, and you need to make a plan. So the way the guys are doing it on the mine is that they are either using water to suppress the dust, or a combination of chemicals and water to bind the soil in the surrounding areas where the trucks operate. And then also in terms of a track system, you need to really have a good and proper water license or general authorization to be able to have the right volumes. And then the last thing is that if it's a PEG system, the last 2 plants that they will be building now will be not the last 2, but the next 2 will be PEG systems. And then obviously your robotic cleaning will be quite important there to get right. But we recently saw a site about 6 or 7 weeks ago where the dust deposition is so severe that those modules, it's a fixed situation, but they washed every single day. And still, it becomes a nice project for the community, and the community start feeling involved as well, and they're quite proud of what they're doing there. And then, as we've spoken about, the topology is not always ideal. for motorized tracker solutions that was handled in the previous slide. Next slide, please. So I did briefly mention the communities. I mean, it's absolutely key to have a good relationship with the communities, to actively engage with them. Once you start announcing and doing your public work in terms of the environmental authorization process, the word spreads quickly. And before you know it, there's a knock on the door of the mine, people wanting jobs. So as Nicola mentioned as well, with the mining companies having quite mature stakeholder engagement systems and measures in place, it becomes easier. All of the communities and so on are known to them. And it's quite easy to work through the client liaison officers, or community liaison officers rather, to speak to the local people. What's unfortunate is obviously when you start recruiting, you always look at the community first, the people in the area. But what's not happened really is that there hasn't been a lot of skills transfer. And so sadly, one usually just gets unskilled labor from the communities, and one hopes that there's some skill transfer that will at least get some of them to a semi-skilled level where they can deploy that somewhere else. So also, if you don't engage them well, we've had various instances of bullets being fired into the plant and people driving by and so on. So it can get out of hand. So it's really critical that you make provision for all of that. The last point there is Nicola's point, saying bulletproof modules would have been nice, but not sure you can build those. Next slide, please. Okay, so I've had a few discussions with some colleagues and friends in the senior lending business and the banks. So really what's interesting, if we can speak about the mining company dynamics first, when this whole renewable energy drive started with mining companies. In fact, the mining sector was the first sector that started looking seriously at this in terms of a utility scale application. The mining executives were quite suspicious about the technology and this sort of esoteric asset class that's going to take space on their land and compete with their mining capital. So initially it was a difficult conversation to try and convince the execs and the board of the renewable energy investments required. Specifically, they were upset and not willing to capitalize the PV plants onto their balance sheet, because obviously then your gearing ability slightly dilutes as a result of that. And again, directly in competition with mining capital. And then also, they couldn't really understand why they should make a large capital investment now, only to realize an OPEX saving going forward. But as soon as you show them the financial models, specifically on the behind-the-meter plant, they are sometimes convinced. And now what we see is that it's almost become priority capital for mining companies and large industrials. Because, not only because of the energy security that you can get if you have the right amount of battery energy storage systems, but also the economics are just really, really great on these plants. Then the senior lender views, obviously the large banks only deal with tier 1 and sometimes tier 2 mining clients. They need to familiarize themselves and get comfort with the profile of these businesses. What is very, very key to them, as you know, is life of mine. And also to look deeply into the commodities and the dynamics and so on and so forth to make sure that the cash flows will be there to service the debt and provide the equity returns. So initially, in the early years, all of the deals were bilateral agreements or arrangements. Basically, a power plant that's behind the meter and the mine is an off-taker. So the issue of that is you cannot really send back into the grid, power back into the grid if you're not geared for that. In fact, with these behind-the-meter plants, your self-built works and monopoly works are usually geared for exactly that, is to build in enough protection to not for the PV plant to mess with the grid's integrity and power quality. So it's not that easy. We saw that many times where a lender comes along, they're crazy about the deal, they're comfortable with everything else, but they ask you, so when can you push your power back into the grid? And you have to say to them, look, it's another year because, or shorter because of the, you have to rework your grid application all over again to be able to provide for that. So it's not an automatic switch over. What the banks are excited about is that, as Rob also mentioned, the whole market is moving towards a liberalized market. So they prefer obviously diversity diversification into the revenue lines, which means that debt serviceability is de-risked. They like the open access and wheeling agreements, power purchase agreements, and then the trading market that's opening up. So if you go to any bank now, and maybe I'm speaking out of turn, and you go with a bilateral distributed generation opportunity, the first thing they will ask you is, can you provide power to the grid or not? And even if it's net metering, you're limited to the benefit that you can get, because you recoup only the variable charges of your Eskom bill up to the extent of your actual power bill. So not a great solution. And then so they like the new liberalized market, and then they look at power purchase agreements themselves for 14 years and longer. So even the banks are changing their views with the change in the market. Rob, that's all I have. Thank you very much.
Cool. Thank you, Kobus. As I said, I don't see any specific questions for you. Maybe just go back to the last slide if you don't mind. But I do have questions for you. Sorry, Jevon. I'm just going to give Kobus a few questions first. Thank you. So Kobus, I mean, one comment first was you talked about the groundwater and that. One of our clients was a sugar mill, and the site they had the 1 in 50 year flood the 2 weeks before our site visit. So when we did the site visit, it was underwater. So that was an interesting one to try and explain away. And yes, we understand significant impacts on efficiency. So on your panel efficiency there, how have you structured it around the fact that there's this impact from dust and quality? Is that affecting the O&M contractor? I'm actually not sure if, are you the O&M contractor there? And how are you passing that risk on, or are you taking on the obligation of cleaning?
No, look, in terms of
you mind popping on your camera again if you can? Sorry.
Sure.
Thank you.
Look, so UV is the O&M contractor on both plants at the moment. And look, in terms of the O&M agreement, there are sort of guarantees in terms of power that will be available, and then some damage clauses, as you can imagine. So what one does is you model the dust. There are dust models available, and you determine what your washing regime should be based on the risk of that happening. And one always needs to provide for the ability to wash a little bit more in case of severe circumstances, as you've mentioned in the case of the water now. So it's quite critical that in your volumes that you put forward to the department of water and sanitation, that you have enough volume prescribed in that for your actual washing regime. So that's how you do it, and but it's up to the owner, operating and maintenance manager, to make sure that those modules are clean enough so that you get your power targets realized.
Cool, thank you. One more question. I just want to make a comment first. So, I mean, we went through that same example. Unfortunately, we've never been your advisor. Hopefully that could change. But around exactly that same thing around, do I use my own money? Do I use someone else's money? IFRS, not IFRS. So exactly that. But what we have seen at the moment is that project finance is quite an expensive experience when you add the lawyers and the finances in. So we often see now where mines will build it on balance sheet, take out all that, build it on an EPCM basis, de-risk the project, and then refinance it on a limited recourse basis, not quite project finance, retain 25% and then get that long-term funding into the balance sheet, because I know miners typically can only raise 8-year money, but for some reason you'll fund a renewables at 16-year money. It's a bit of a weird, so we have seen that. But the question for you is, the market's coming, you are going to be a balance responsible party under the new market rules. How are you as an entity, you're above 10 megawatts, how as an entity are you preparing for the market? Like, obviously, you're doing this on-site stuff and that. What are you doing, the market grid code, that sort of stuff, to potentially de-risk yourselves? I know you're probably not going to be a trader, but it's a risking mechanism.
No, absolutely. Look, there's a lot of innovative structuring that you can do from a debt or financing point of view. As an example, this client of mine, Pan African Resources, has raised a green bond with Rand Merchant Bank, which is quite interesting because as you realize your ESG targets, your pricing gets lower in terms of debt costs. So that's quite an incentivized structure for you to get all of your ESG developments done. And look, I can't speak for Pan African itself, but I think with the power purchase agreement that we signed about 2 weeks ago with NOAA Group, NOAA Energy, of 40 megawatts over 10 years, that should help make use of the, shall we say, more open market. And then, everything is fluid. You just adjust to whatever's happening in the market. As long as you get the benefit from it and you put yourself in the best position, then you're ready. You can go along.
Cool. Thank you very much. Thank you for your presentation and the questions. Jevon, do you want to take us home? Thank you.
Yes, thanks, Rob, and thanks to the Cresco team for having me here today. Just by way of introduction, my name is Jevon Martin. I'm responsible for business development at Etana Energy. Historically, I led the energy and decarbonisation strategy for a large listed company, and in that role developed over 200 megawatts of greenfields solar PV projects and also closed over 400 megawatts of wheeled projects. So hopefully can bring a couple of different perspectives today. But maybe we can just go to the next slide. Just quickly introducing, sorry, one slide back. Okay. Seems to be a slide missing, but maybe just quickly introducing Etana Energy. Etana Energy is a renewable energy trader. We want to unlock renewable energy in the country. We've been established through a number of leading partners, including H1, Charitable Artisanal Energy. Some of our shareholders include Standard Bank, Norfund, and we've also been granted credit facilities by British International Investments and Garanco, which give us around 2.8 billion rand to roll out a 750 megawatts pipeline. We're a NERSA licensed trader, been trading since 2022. And what we really do is we buy renewable energy over long-term PPAs, package that into smaller, more flexible contracts to be sold to smaller C&I customers across the country. In terms of today's presentation, I really want to quickly talk about 3 steps that you can use to enhance your embedded generation strategy. Some of my colleagues have spoken around the challenges of embedded generation, and we want to talk about sort of what those next steps could be for you as a energy consumer in South Africa. The first one being leveraging complementary wheeled renewable energy. The second is unlocking the full potential of battery energy storage, and Rob spoke to that earlier. And then lastly is preparing for the launch of the wholesale energy market. So if we can go to the next slide, please. Rob also spoke to this transition that we've seen over the last 10 years. 10 years ago, we would have received as a consumer just traditional utility supply, very simple. You received your invoice at the end of the month. You did a reconciliation of meter data versus what's on the invoice, and you sign off. With onset of load shedding, above inflation escalations, the focus on decarbonisation, there's been a spur of embedded generation. We've, as a country, unlocked over 4 gigawatts of rooftop embedded and carport solar, but that has its limitations, as we've heard today. And I will talk to you a little bit about that just now. We believe the next frontier is really wheeled generation. We've seen a spur of bilateral PPAs that have been closed across the country, over 3 gigawatts of renewable energy projects going into construction. But simultaneously, we've seen a slowdown in projects moving to close as some of the large power users fill up their buckets in terms of renewable energy. And that's really where the traders come in. Traders, by aggregating demand, are now beginning to unlock renewable energy projects and moving those into financial close. The next frontier after that, and hopefully we see the launch of the liberalized wholesale energy market in 2026, is really the next opportunity for consumers, IPPs, traders to interact with each other through this wholesale market. But as we move from left to right, we're seeing increasing choice and opportunities, but with increased obligations and risk. If we go to the next slide, please. We believe the first step that you should take in terms of your energy strategy is leveraging complementary wheeled wind and solar. As we've heard today, developing on-site embedded projects has its own challenges. Typically, it is very commercially attractive. It is somewhat easy to deploy in terms of rooftop and carport projects. But as soon as you move into utility scale projects, you run into the long lead times of developments, you run into grid constraints. A number of projects are constrained grid-wise across the country, including embedded projects in the Northwest and soon to be the Free State, the Northern Cape, Western Cape, and the Eastern Cape already locked out. And they're also commercially complex to get those to financial close. Typically, if you have embedded solar PV project, you can get to renewable energy penetration levels of 0 to 40%, depending on your load profile and the solar PV that you're building. But if you combine that embedded solar PV projects with wheeled wind and solar, which offers geographical diversification, a blend of different generation projects, you're able to get to a much higher level of renewable energy penetration and energy supply around the clock, around the year. So effectively, if you introduce wheeled renewable energy in combination with your embedded solar PV projects, you can get to much higher level. And through traders, you can actually mitigate any excess energy risk through their broader customer portfolios. And through that, you can get to higher savings and to 65 to 90% renewable energy penetration. We'll go to the next slide, please. The second step we believe you should take, and Rob spoke to this earlier, is really considering the deployment of battery energy storage systems across both the gen side and on the load side behind the meter. Traditionally, when we think about battery energy storage, there's sort of three primary benefits, being peak shaving, energy arbitrage, and primary backup. And that's been the sort of core business case that's allowed a number of battery energy storage systems or BESS systems to be unlocked across the country. But as we move to this liberalized market and we see more higher embedded generation, higher wheeled energy, those BESS systems will allow greater load and generation flexibility, allow you to get to higher renewable energy penetration, and you'd be able to reduce the risk of any overbuild or excess energy introduced into your portfolio that you would have encountered if you had not considered battery energy storage. Battery energy storage also allows you to build resilience to market changes, including tariff structure changes. We anticipate that midday power will decrease in value as there's higher solar penetration across the country. And then lastly, you'll be able to unlock new revenue streams by incorporating battery energy storage within your portfolio. You'll be accessed potentially through the likes of traders, or if you become a direct market participant, you can play on the capacity market, you can use the BESS for balancing purposes, or you can potentially offer ancillary services back to the system operator. Next slide, please. If we could, Mimilek, if we can go to the next slide, please. Thank you. The third component we believe, or the step you should take as an energy consumer in South Africa, is prepare for the launch of the wholesale energy market. We believe this is going to open up a number of opportunities for consumers in South Africa, from direct market access or potentially through an intermediary like a trader. It'll create opportunities for energy arbitrage and excess energy management. And I mentioned you'd also be able to potentially partake in new products, like flexible products, like demand-side energy products, ancillary services, and you can also use it to optimize existing assets like battery energy storage. But with that, there will come obligations. Rob and Nicholas spoke earlier about scheduling obligations. You'll need to forecast your demand and supply on a day-ahead basis. You'll need to schedule that. And if you're out of balance or you're imbalance, you'll be subject to penalties levied through the market. There's automatic balancing responsibilities for generators greater than 10 megawatts. And then a further obligation is you'd have to be put up prudential security for your participation in the market, including credit cover and settlement timelines. Lastly, there are some risks, including market volatility, penalties I mentioned, and there's definitely going to be transitionary uncertainty in the near term. But it's critical you think about these combined elements as you're starting to shape your energy strategy, and think about partnering with trusted parties within the industry to act on your behalf, potentially as the intermediary. If you go to the next slide, just conscious of time. So again, we believe there are 3 critical steps to lift your energy strategy. Those 3 steps that I mentioned earlier will lead to high renewable energy penetration, increased savings, and superior market resilience. We believe that partnering with a trusted player like Etana Energy will future-proof your energy strategy. Thanks, Rob.
Good run at the end there. Thanks.
Bit of time pressure.
You could see the line and you started running towards it. So there is a question for you here in the thing from Ven and Wholesale around MV connections and wheeling, and I guess it talks to virtual wheeling or wheeling to municipalities. I know Etana has a wheeling deal into Cape Town. I don't know if you just want to touch on that. I don't know if you can see the question or happy
Let me just bring up the question quickly.
Yeah.
At the moment, traditional wheeling is primarily what a number of trader and bilateral projects have been banked on. The banks are generally comfortable with this. Virtual wheeling has launched, which will enable wheeling to LV connections as long as you're on a time of use tariff. There are some challenges still with that. We've seen the Eskom's opposition to it. I know from the lender side and from the legal side, there's a number of challenges. Some other parties have put virtual wheeling on hold. But we do believe virtual wheeling issues will be ironed out in the future. And like Etana Energy, we're preparing to supply customers through virtual wheeling or some of the other wheeling mechanisms that are emerging. So we believe that the restriction around being sort of a customer on north of a 1 kV connection with the time of use tariff is temporary. We believe that there will hopefully be further liberalization of wheeling and access to further customers in the near future.
Cool. And then last question, 2 minutes. So, I mean, I hope you agree that PV and BESS for new projects is a no-brainer, but how far do you think wind and BESS in terms of wheeling, because we don't see very many behind the meter wind projects, unfortunately. How long before you think that becomes something of interest from a pricing and a requirement point of view?
Yeah, I think solar and BESS behind the meter is, like you say, a no-brainer, but it does have its challenges in speed of deployment, especially if it's utility scale. You're looking at a 2 to 3 year development window, and with impending grid constraints around Gauteng, Northwest, Free State, it's going to become more and more difficult. Wheeled solar and BESS is definitely something we're going to see a lot of in the very near future. I think quite a few projects that are going to be announced in the next 12 months are going to contain an element of BESS. Wind and BESS, not so much. I think wind itself has the benefit of producing on average across a 24/7 period. But we will definitely see BESS starting to be incorporated on the gen side of wind in the future as the market opens and you see balancing responsibilities. But I think there's a strong case to be made to have BESS on the customer side and managing a lot of the balancing responsibilities sort of as a pool with that on the customer side where you probably derive the most benefit as a sort of collective.
Cool. Thank you. So we're on the hour. Thank you very much, Jevon, for your time. And thank you for all the other speakers too. As we said, a recording and presentation will be out next week. And we will confirm the hydrogen webinar probably next week once we've confirmed all the speakers. But thank you for joining us today on a Thursday. Have a good afternoon. Thank you very much. Cheers. Bye-bye.